discuss diagram for allylic system. Allylic system is total 3 types. Allyl cation, allyl anion, and allyl radical, allylic system. It may be cation, it may be anion, it may be radical. Whatever is there, how to draw its diagram. So in order to draw its diagram, so it's very important that you first decide how many you can have how many different pi center. Okay, so once you decide the number of pi centers, then you can get idea about how many bonding orbitals are there and how many anti-bonding or non-bonding orbitals are there. So in the case of allylic system, one pi bond is there, CH2 double bond CH, CH2. So one pi bond is there. Now, if you put here positive charge, then it is called allylic cation, which is having 2 pi electron. Allylic cation is nothing but 2 pi electron system. This is having 2 pi electron. If you put here odd electron, then it's a allylic radical. How many pi electron? It's a 3 pi electron. Okay, this electron can take part in the resonance, so it is also called pi electron. If you having allylic anion, then you can have a negative charge here. So this is a 4 pi electron system. So in this way, you can have a different system. So how many pi center are there?
3.
3 pi center. So pi electron and pi center both are different things. Pi electron J center per hoy, that center is we called pi center. So there are 3 pi centers, 3 carbon atoms are there, and at all these 3 centers, pi electron are equally distributed. So you can have a 3 pi center. Good. So total nodes is equal to n minus 1. How many?
2.
2. Now 3 pi center are there. So if you have a 3 levels, so one is non-bonding because this positive charge or this 1 electron or here 2 electron, that remains as a non-bonding. So one non-bonding level is there. This is non-bonding and one bonding and one anti-bonding. You can have a 3 levels. First level having node 0, that is called bonding level. Then node 1, that is called non-bonding level. This is a non-bonding. See. And you can have a, this is bonding. You can draw this structure in whatever way. If you want to draw it in a something like this way, so you can draw this way. Then here it is non-bonding levels, and here it's a bonding levels, that is 2 node. And here it's a, you can say Non-bonding level. Now you tell me where is node in first level, psi 1? How many nodes are there?
0.
0. So all the upper, all the, no, but in first level, total nodes are 2, but in psi 1 it is 0. So for all the upper portion are shaded. Okay. Now what about in second level? How many nodes are there?
1.
1. તો એ node center માં લેવો પડશે તમારે. You can take the node into center. So therefore see this is center. So ત્યાં orbital missing બતાવવાની. You cannot write orbital here because on the orbital or on this atom there is a node. So this is a shaded and this is lower portion is a shaded in this way. You can show the first node. In odd number of pi center are there, the node is comes in on into the position of atom. What's about in second level, psi 3, third level? There are 2 nodes. So first node is between atom number 1 and
2, 2 and 3.
1 and 2 and 2 and 3.
પણ એમાં સર બંને બે સેમ થઈ જશે ને બીજો
Same
ને
ના થાય.
ત્રીજો.
This upper portion shaded, here lower portion unshaded. Sorry, lower portion shaded. So if there is one node between these two. અહીંયા upper portion shaded કરો. બંનેમાં difference છે ને? બીજું ને ત્રીજું ક્યાં same છે?
Yes.
So these are the C3 levels. Now if you go for thermal reaction, see this diagram is common for all the systems, whether it is Allylic or it may be, you can say, whatever system is there, this diagram is common. So this is level 1, here level 2, level 3. Now if you draw the diagram for Allylic cation, suppose your system is Allylic cation. So how many electrons are there? There are
6.
6 now cation.
Total 6 times.
Allylic cation માં
सब 2 इलेक्ट्रॉन था सर.
2 electron. So 2 pi electron. 1 pi bond is there. આપણે diagram તો separated draw કરવાનો હોય બધાને કોઈ પણ એકનું જ પૂછે, but we are writing here see combined together. Then allylic radical, how many electrons?
3 इलेक्ट्रॉन.
2.
Radical માં 2 છે? Radical માં કેટલા ઇલેક્ટ્રોન છે?
3 sir.
એ છે. તમારું સિસ્ટમ જે છે એમાં શું એન્સ્પ્રી માં જોઈન્ટ કર્યું છે, કેવી રીતે જોઈન્ટ કર્યું છે? તમારે છે ને જવાબ મેક્સિમમ તમારા તરફથી આવે છે, પટેલ નિપા. અને બેકઅપમાં પટેલ નિધિ છે, નિપા, બરોબર. તમે હેન્ડસ્પ્રી થી જોઈન્ટ કર્યું છે, કેવી રીતે જોઈન્ટ કર્યું છે?
સર એમને હેન્ડ સ્પ્રે નથી નાખ્યા.
તો હેન્ડસ્પ્રી કે એવું કંઈક હોય ને, સ્પીકરમાં શું રિફ્લેક્ટ થઈ જાય, અવાજ બેકઅપ આવશે એટલે
સર
ઠીક,
ઓકે.
હે ને? કારણ કે મેક્સિમમ જવાબ તમારે આવશે એટલે આમાં રેકોર્ડિંગ થાય ને એટલે બેકઅપ આવે એટલે અવાજ થોડો સ્પ્રેડ થઈ જાય. હેન્ડસ્પ્રી હોય તો હેન્ડસ્પ્રી જોઈ લ્યો જરા. ચાલો જો પછી નેક્સ્ટ આવશે allylic anion. હાઉ મેની electrons are there in thermal and photochemical? 4 electron. Okay, so in the first case you can have a 2 electrons and they are accommodated in, both the electron are accommodated in psi 1. So this is your HOMO and this is LUMO psi 2. In photochemical reaction, one of the electron gets excited to psi 2, so this become now HOMO, and this become LUMO. This is the case with cation. In the case of anion, what happens? So in the case of radical, there are 3 electrons. What happens? 2 in this level and 1 electron is in this level. So this become HOMO. This become LUMO. Now if you go for photochemical reaction, then one of the electron gets excited from psi 2 to psi 3 in this way. So this become your HOMO. Now next, in the allylic radical, sorry, allylic anion. This is allylic anion. You can have a 4 electron. You can accommodate in this way. Now one of the electron from psi 2 gets excited to psi 3. So this is the way you can have a C diagram for all these 3 systems. Now if you talk about symmetry, so you tell me the first level is mirror plane symmetric or asymmetric?
Symmetry.
First is mirror plane symmetric. You can put C mirror here. The mirror plane symmetric. Psi 1, psi 2, psi 3. Mirror plane and C2 axis. First level is symmetric. Second level, asymmetric. Third one, symmetric. What's about first level C2 axis? Asymmetric, symmetric, then asymmetric. Okay. Everybody have clear this one?
Yes.
Okay,
Yes, sir.
fine. So what happens? See, this is FMO theory. You can choose highest occupied molecular orbital and lowest unoccupied molecular orbital for any type of photochemical reactions in order to predict which reaction is allowed or which reaction may not allowed. Now, similar to this, another theory, second very important theory, that is, you can say it's you can have a Woodward Hoffmann correlation theory. This is the FMO approach where you have drawn different MO diagrams. Now, then next is Hoffmann correlation diagram. That is again give you same result but in a different way. It's a different principle. Hoffmann correlation. Approach or diagram or method, you can say. So see what happens in the case of Hoffmann correlation diagram. So see, we have already mentioned symmetry in a different orbitals, on a different levels. We have already mentioned symmetry. So in the case of Woodward Hoffmann correlation, you can have a very important thing is you have to match the symmetry of reactant with the symmetry of product. This is the diagram which is applicable to both electrocyclic as well as cycloaddition reaction. So first you find the element of symmetry, okay, and then you can find the different correlation. So what you can do, if conrotatory motion is there, it always, if conrotatory motion is there, conrotatory motion always maintain C2 axis symmetry. And if this rotatory motion is there, it always maintain mirror plane symmetry. These things you can keep in mind. Now, our first question is what is conrotatory motion? What is disrotatory motion? So see, conrotatory motion means rotation is given in a same direction. Rotation is given in the same side. Either clockwise or anti-clockwise. Disrotatory motion means rotation is given in opposite direction. For example, see this is your dyne, which having see here trans geometry. So hydrogen is of course here. Here also trans geometry. This is a single bond we extended it. Now suppose if you want to give conrotatory motion, then what happens? Conrotatory motion means rotation is given either in clockwise or in a anti-clockwise. So this is in a clockwise. This is in a clockwise. So બંનેમાં arrow છે અહીંયા જો મિથાઇલ પર arrow આવે છે. Here arrow is comes on hydrogen. That means hydrogen and methyl are in a same direction. That means both the methyl group are in opposite direction. Methyl group is drawn by dark line. Here it is by dotted line. Both the methyl group are in opposite direction. You can have a two product. Either you can give clockwise rotation or you can give anti-clockwise. This is called conrotatory motion. Okay. Now this rotatory motion. So one bond is rotated in a clockwise direction, another bond is in anti-clockwise. બંનેમાં એરો હાઇડ્રોજન પાસે આવે છે. That means both the hydrogen are in the same side and both the methyl group are in the same side. You can write down either 2 methyl group on your side or 2 methyl group on back side. Both are same product because plane of symmetry. These two are not a different product, but it's a meso compound. So this is called conrotatory and disrotatory motion. Is it clear?
Yes, sir.
Conrotatory motion ક્યારે use કરવાના? કોઈ symmetry હોય તો?
Different.
C2.
C2 axis. And disrotatory માટે you can have a mirror plane symmetry. Look at here. So now you can have a, suppose system is, if you want to draw a diagram for Woodward Hoffmann correlation diagram for this type of ring opening reaction, or you can say ring closing reaction. But before going to draw this diagram, you can keep one thing in mind, that pi orbitals. See, we are having two types of bond, pi and sigma bond. So pi orbital is always, pi orbital always having symmetry. That is, you can take a case of ethene. Symmetry with the pi orbital is, you can have a case of ethene. What's about ethene? Pi orbital and pi star. If you talk about both the orbitals for the case of ethene, then mirror plane and C2 axis. What happens in the case of pi orbital? You can look at here. This is pi orbital in the case of ethene. This is your pi star. What happens? Mirror plane symmetric or asymmetric?
Symmetry.
Symmetric. C2 axis?
Asymmetry.
Symmetry.
Asymmetric. Pi star, asymmetric, and symmetric. Similar basis, sometimes pi bond may converted to sigma bond, or sigma bond may converted to pi bond. So in that case, what about sigma and sigma star orbitals? So this is your sigma and sigma star. Mirror plane and C2 axis. So this is the sigma bond, it is a linear. This is your sigma bond. What's about C2 axis? What's about mirror plane?
Symmetric.
Symmetry.
Mirror plane symmetric and C2 axis?
Asymmetry.
180 રોટેશન આપો તો એસિમેટ્રિક થશે? સિમેટ્રિક જ આવશે. આ પ્લસ પ્લસની જગ્યા આવશે, માઇનસ માઇનસની જગ્યા આવશે, લિનિયર છે મોલિક્યુલ. તમારી બાજુ લઈને રોટેશન આપશો તો પણ સિમેટ્રિક જ આવશે. બોથ આર સિમેટ્રિક. This is difference between pi orbital and C2 axis because this is non-linear, but this is a linear. Sigma bond is a linear. What's about sigma star? What is called sigma star? First we understand it. So sigma star is nothing but here it's a plus minus. This is called antibonding. What happens in the both the case?
Different.
Both are asymmetric. Both are asymmetric. So now, if you want to draw correlation diagram for butadiene or sorry, for electrocyclic reaction, ring opening reaction, Hoffmann correlation diagram. For below reaction. So this is your reaction. One pi bond and one sigma bond. If you go for ring opening reaction, that is for electrocyclic. So this is the product. This is the thermal reaction. If you want to draw Hoffmann correlation diagram for thermal foreign system, this is called C 2 pi electron and 2 sigma electron. Here one this is a sigma bond. Remember, this is a sigma bond and this is a bonding level with lowest energy. So this is plus, minus, minus, and this is one pi bond. So this is a foreign system, 4 electron system, 2 pi electron and 2 sigma electron. This is having 4 pi electrons. So this is also foreign system. Now what you can do, if you want to draw thermally allowed reaction, foreign system is thermally allowed or photochemically, if you want to check it. So you can go on both the way. Whenever you are applying conrotatory motion, if you want to check whether conrotatory motion is thermally allowed or photochemically allowed. Okay, so how you can check? You can check in this way. Foreign thermally conrotatory, suppose if you want to draw diagram for conrotatory motion. So what happens? So this bond goes on which side? You can extrapolate this line. This one goes on this side clockwise. This is also in a clockwise. So what is transition state? This type of transition state is there. A positive નીચેની side આવશે. Negative ઉપર જશે here. Positive goes to above the plane and negative comes below the plane. ચલો આ બંને વચ્ચે બે ભાગ સરખા છે કે જુદા જુદા?
Different.
Different here. Okay, so this is your in short it is a transition state. So what you can do, you can write down first here symmetry, here one sigma bond and one pi bond is there. So you can have a 4 level, one sigma level, then one pi level. This is non-bonding level. After that, then here it's a pi star and sigma star. These are your level. Now you can go for conrotatory motion. तो कई symmetry लेवानी बोलो?
C2 axis.
C2 axis. Look at here. C2 axis sigma કેવું છે? સિગ્મા અને સિગ્મા સ્ટાર બંને કેવા છે એ જોઈ લ્યો.
Different.
ડિફરન્ટ એટલે સિમેટ્રિક કે એસિમેટ્રિક એમ પૂછું? કોણ
Symmetry.
સિમેટ્રિક?
Asymmetry.
કોણ સિમેટ્રિક છે? સિગ્મા સિમેટ્રિક and sigma star
Sigma
asymmetric.
star is asymmetric.
This is symmetric and this is asymmetric. Okay. What's about pi and pi star? Ethene no guess do. C2 axis pi and pi star.
Asymmetric.
Asymmetric.
Now in the case of product, that is 4 pi electron, so it is a butadiene and butadiene no diagram તમને ખબર છે. Butadiene having 4 level, that is called psi 1, psi 2, psi 3, psi 4. This is a butadiene. So what's about psi 1 level? In the case of butadiene, this is a butadiene. We are talk about psi 1. Psi 1 કેવું છે? C2 axis symmetric છે કે asymmetric?
Asymmetric. C2.
Asymmetric છે. પછી બધા પછી symmetric, ફરી asymmetric એ રીતે આવે છે. So this is asymmetric. Psi 2 is symmetric. Psi 3 is asymmetric. Psi 4 is symmetric. Now you can correlate symmetry of reactant with the symmetry of product. So these two are correlated. These two are correlated. In short, see, bonding orbital are correlated. Anti-bonding orbital are correlated. So therefore, no crossover. Crossover કોને કહેવાય? Whenever you are having correlation of bonding with anti-bonding. But આ કેસમાં એવું નથી. Here this is anti-bonding molecular orbital. This is bonding molecular orbital. There is no crossover, and whenever the crossover is not observed, then reaction is thermally allowed, and therefore there is no crossover between anti-bonding molecular orbital and bonding molecular orbital. Therefore, reaction is thermally allowed. And therefore, you write down here reaction is thermally allowed. there is no crossover. Okay, crossover થાય તો it's photochemically error. See, if you construct same diagram for, you can have a ring opening reaction for with a disk rotatory motion. Disk rotatory motion, ring opening. This is a two different level. What you can do, see, here motion is disk rotatory. So first what you can do, disk rotatory motion no meaning શું છે, કઈ symmetry લેવાની?
Different.
Sigma
Right.
plane.
Sigma પણ different લેવાનું.
સિગ્મા પ્લેન તો સેમ જ રહે ને, થોડા બદલાય તો જે સિગ્મા પ્લેન ચેન્જ થાય છે. મિરર પ્લેન હોય તો સિમેટ્રિક છે, સિગ્મા ને C2 એક્સિસ હોય તો સિમેટ્રિક છે. હું એવું પૂછું છું, ડિસ રોટેટરી મોશન છે એટલે કઈ વસ્તુ તમારે કઈ સિમેટ્રી લેવાની? સિમેટ્રીમાં બે પ્રકાર, સિગ્મા પ્લેન અને C2 એક્સિસ.
Sigma plane આવશે.
મિરર પ્લેન લેવાની સિમેટ્રી. રૂલ્સ જ આપી દીધો છે ને તમને. રૂલ્સ છે કે જ્યારે પણ કોનરોટેટરી મોશન હોય તો કઈ સિમેટ્રી એપ્લાય કરવાની? C2 એક્સિસ. અને ડિસ રોટેટરી મોશન આપવું હોય તો મિરર પ્લેન.
Mirror plane.
એટલે અહીંયા મિરર પ્લેન સિમેટ્રી લેવી પડશે. સી હિયર મિરર પ્લેન. એ તમને મેન્શન કરી દીધું છે. કોનરોટેટરી મોશન હોય so always go for mirror plane. Sorry, conrotatory હોય તો C2 axis and disrotatory હોય so you can have a mirror plane. So what's about sigma mirror plane? Sigma is both symmetric and sigma star is both asymmetric. So sigma level is mirror plane symmetric or asymmetric? જોઈન તો કયો, સિગ્મા મિરર પ્લેન સિમેટ્રિક છે કે એસિમેટ્રિક? સિમેટ્રિક. સિગ્મા સ્ટાર એસિમેટ્રિક. What's about pi and pi star? ઇથિન નો કેસ છે, મિરર પ્લેન. Pi and pi star are mirror plane symmetric and asymmetric.
Asymmetric.
Pi level કેવું છે?
Symmetric.
Pi level symmetric.
Symmetric છે and pi star is asymmetric.
Asymmetric.
Now here it's a butadiene, that is psi1, psi2, psi3 and psi4. What's about butadiene? First level is mirror plane. Psi માં બધા જ ઉપરના લો પ્લસ આવતા હતા ફર્સ્ટ લેવલ butadiene માં. તો મિરર પ્લેન કેવું હોય? psi1 સિમેટ્રિક.
Symmetric.
psi2, this is your psi2. એક નોટ આવતો તો અહીંયા વચ્ચે. psi2 is asymmetric. What's about psi3?
Asymmetric.
Psi3 is symmetric. This is psi3.
Symmetric.
Symmetric, good. અહીંયા બે નોટ આવશે. psi4,
Asymmetric.
Asymmetric because alternate node also. So you can correlate symmetry of reactant with product in this way. These two are correlated with each other. These two are correlated with each other. Now these two are correlated with each other. So here see what happens. Crossover is observed between bonding molecular orbital and anti-bonding molecular orbital. Crossover is observed in symmetry, and therefore it is photochemically allowed. So this reaction allowed photochemically, distortatory. This is the case for Butadiene system. Now what happens if you take hexatriene system, 6N, this is 4 pi electron butadiene and 1 sigma bond, 4 pi electron, 2 sigma electron, or you can say 2 pi bond and 1 sigma bond whenever you are go for ring opening. Via Conrotatory motion. So we are getting this one. So you are getting hexatriene. See, hexatriene is a 6 pi electron system. Now you are talking about which motion? Conrotatory. So which symmetry is applied?
C2.
C2. One sigma bond is there, so you can have a 2 orbitals, sigma 1 and sigma star. Another system is butadiene system. Here you can have a say this is a butadiene part. And this is 2 sigma electrons. So this is sigma is C2 axis. Sigma bond is always whether C in case of C2 axis. If you go for sigma, so it is symmetric and sigma star is asymmetric. Same way here you can write down asymmetric. Butadiene first level is just now we have just earlier we have seen it. First level is C2 axis asymmetric. Second level is second level. Butadiene માં ખબર નથી second level C2 axis symmetric છે કે asymmetric? Psi 2 is symmetric or asymmetric? C2 axis जो हो तो
Symmetry.
સિમેટ્રિક છે. psi 3
Asymmetry.
ઓલ્ટરનેટ જ આવે. સિમેટ્રિક ફર્સ્ટ લેવલ ખબર પડી જાય તોય આવડી જાય. ફર્સ્ટ લેવલ તો દરેકને આવડે જ ને, બધા ઉપરના લોબ પ્લસ હોય. તમે કોઈ પણ સિસ્ટમનો ડાયાગ્રામ દોરતા હોય એમાં ફર્સ્ટ લેવલ psi 1 તમને ખબર હોય એટલે બધું જ આવડી જાય. psi 1 જે છે એમાં ઉપરના લોબ બધા પ્લસ હોય, બરોબર. એ મિરર પ્લેન સિમેટ્રિક હોય ફર્સ્ટ લેવલ, અને C2 એક્સિસ એસિમેટ્રિક હોય. એ જ રીતે તમારે બાકીના લેવલ્સ જાતે પ્રેડિક્ટ કરી શકો. નાઉ હેક્ઝાટ્રાઇન જે છે એના માટે 6 લેવલ આર ધેર, ધેટ ઇઝ psi 1, psi 2, psi 3. 3 are bonding and 3 are anti-bonding. હમણાં જ મેં કીધું ફર્સ્ટ લેવલ બધાને ખબર હોવી જોઈએ એટલે બાકીના લેવલ જાતે લખી શકો. ધીસ ઇઝ યોર ફર્સ્ટ લેવલ. Always first level is which symmetry? It has mirror plane જ હોય એટલે ઓટોમેટિક C2 એક્સિસ શું આવે? સિમેટ્રિક આવશે કે એસિમેટ્રિક?
Asymmetry.
It is always asymmetric. પછી ઓલ્ટરનેટ જ હોય છે, એક લેવલ યાદ ના હોય તો. Now how to draw correlation diagram? So this is the way to draw correlation diagram. These two are correlated with each other. These two are correlated with each other. So what happens? Symmetry of reactant is correlated with symmetry of product. Now these two are correlated. So see here crossover is observed. So what happens? This reaction is thermally allowed or photochemically?
Photochemical.
બોલો આટલા એક્ઝામ્પલ થઈ ગયા, નવું નથી.
Photochemically allowed.
Photochemically allowed. Good. That is a photochemically allowed. So you can say that 6N system photochemically conrotatory, અથવા conrotatory photochemically allowed, and 4N system conrotatory thermally allowed. Okay, so this is the selection rule. Now same diagram you can draw for this rotatory motion. What happens? 6N this rotatory. You can have this one. પછી રિંગ ક્લોઝિંગ કરતા હોય કે રિંગ ઓપનિંગ કરતા હોય. રિંગ ક્લોઝિંગ કરતા હોય તો જે લેફ્ટ સાઈડ લખો છો એને રાઈટ સાઈડ લખવું પડે, and right side things are written on left side. Again 6N system, 4 pi electron and 2 sigma electron. If you go for ring opening via this rotatory motion, you are getting this one. In this case here there is sigma star and psi 1, psi 2, psi 3, psi 4. But see here motion is this rotatory, so which symmetry is to be considered?
Mirror plane. Mirror plane.
Mirror plane. What's about sigma in mirror plane? સિગ્મા યાદ રાખવાનો, C2 એક્સિસ હોય કે મિરર પ્લેન હોય બંને કેવું છે? સિમેટ્રિક. મેં ડાયાગ્રામ ડ્રો કરાવ્યો હતો તમને સિગ્માનો આ રીતનો. whether it is mirror plane or C2 axis, બંને symmetric જ આવે. Sigma star is always asymmetric. ચલો psi 1 કેવું આવે butadiene માં ઉપરના બધા જ લોબ પ્લસ હોય psi 1 માં. મિરર પ્લેન સિમેટ્રિક આવે કે એસિમેટ્રિક?
Symmetric.
Symmetric.
સિમેટ્રિક તો ઓટોમેટિક અહીંયા એસિમેટ્રિક આવશે. ફરી સિમેટ્રિક કે એસિમેટ્રિક. વોટ્સ અબાઉટ psi 1 psi 2 psi 3 માં psi 1 હેક્સાટ્રાઇન માં ફર્સ્ટ લેવલ ઓલવેઝ બધા લોબ
Symmetric
ઉપરનો
આવશે.
પ્લસ હોય એટલે મિરર પ્લેન હોય સિમેટ્રિક.
Symmetric.
This is asymmetric, this is symmetric. Now see photo chemical છે કે thermally છે આપણે ચેક કરવું છે. એના માટે we can just compare the symmetry. These two are correlated with each other. These two are correlated. There is no crossover. Crossover થતું નથી. Okay. So there is no crossover. So what happens? And
Thermally
therefore it is
Chemical
thermally
alarm.
alert. Thermally alert. Good. So in short, see, section system thermally disrotatory allowed and foreign system thermally conrotatory allowed. Okay, so what is selection rule? Foreign system is there, then it is always thermally, which motion? Thermally conrotatory is allowed and photochemically
is rotatory.
disrotatory. The major product લખતા હોય ત્યારે આ જ motion આપવાના. Section system is there, then it is thermally
Is rotatory.
disrotatory. Photochemically
Conrotatory.
so this is the selection rule. Okay, so this theory is called Woodward Hoffmann correlation theory. Similar way we will take perturbation theory, Dewars approach. So you can apply this diagram for both the reaction, or that is not necessary. Always go for ring opening. You can have a ring closing. બરોબર તો alternate compare કરવાની. જો લેફ્ટ સાઈડ લખો છો અને રાઈટ સાઈડ લખી દેવાનું, રાઈટ સાઈડ લખો છો અને લેફ્ટ સાઈડ લખવાનું. In the next lecture we will take number of examples as a practice and then we complete this Woodward Hoffmann correlation theory. Of course, before starting that example, we go for Dewars approach and then we will make a practice of certain reactions. Also, we will see cycloaddition reaction in detail, electrocyclic reaction in detail, and two type of addition mode, suprafacial and interfacial. So that all these things we will going to see later on. So thank you very much for joining.